Okay, good afternoon, everyone. Sorry for being late today. So today we are going to cover week 6 exercises. And specifically, I'd like to cover the data model of XML. So, we're all going to focus on the schema of XML and also some JSON. But I'd like to put emphasis on Dremel, which is kind of the crux of the data model part of this course. Okay. And please let me know if anything is invisible to you, and I will enlarge a little bit. First, I'd like to highlight this paper, this Dremel paper. It's quite a seminal paper and highly recommend reading it. And the rest will be optional. Firstly, let's go through some interesting problems very quickly. So in terms of the first exercise, the only thing I'd like to highlight here is that first you always need to have a doc element as the root of any trees. And also the comments should also be a node in the tree. So these two elements are commonly missed in previous years. So please keep that in mind. And the second part for this exercise, so I've put...
Can I ask a question about the trees?
Yeah, so sure.
Because in the exercise, it said that we should regard character information elements.
Right.
And that would be the individual characters of the words, right? Because how it's done there, that's like a text information element, which is, at least it said so in script, which is not like an official element. So
Right. So
we go like this in the exam because it's way less complicated than having to put every single character as an individual element.
I see. So the question is, officially, so if you look at the XML document, there's an element called character element. So basically, every character is an element of this information tree. And should we also put every element as a single node, individual nodes in this document tree? So the quick answer is no. So you only need to put the whole string together. But yeah, technically, yeah, every single character is an element in this information tree. But I don't think it would be reasonable to require you to put every single character as individual nodes. But yeah, that's a good point. And later we'll be looking at when in this document tree can have character elements and when can it not. Thanks for the question. Yeah, quickly moving on. So please stop me if you have any questions for specific exercises. For the sake of time, I will quickly moving on. So for the second question I'd like to discuss is matching document and schema. And this is not specifically a very difficult problem, but it would be a very common question to ask in the exam. So I would highly recommend going through, making sure that you have understood everything. So just to use this question as an example, okay? So let's see. Which schema would I have put the schema and documents side by side, and also schema 5 is quite peculiar, so I singled it out to the next page. But for document 1, which one would validate the first document? If it's visible to you guys. Three. Let me see. Well, 3 is this one, right? But it has a decimal type. Yeah, that's a little. I think sorry? 4. Exactly, yes. So for would validate document 1, that's indeed true. And one thing, later we'll be looking at what a complex type is and why this can validate an empty type. So in this case, just to, so later we'll delve into detail, but basically in this case, this is by default an empty node. Basically, this can validate anything that's empty. And later we'll be looking at why this is a default mode. For document 2, any guesses? So in document 2, what we have is that we have a sequence of elements. And keep in mind that the sequence, the order matters as well. So you can't switch this around. Which one would validate document 2?
First one.
Exactly, first one.
The second one too.
And the second one too, yeah.
Just the last one.
Good point. And the second one, we have a mixed equal to true. Any guesses what this means? Yeah.
The order of the children can be.
Sorry.
The order of the children nodes can be any order. Like you can interpose the children in any way you want.
That's a good guess, but no. Yeah.
There can be like text nodes, just anywhere.
Yes, that's true. So, yeah, I would say like mixing the types of elements would be a reasonable guess, but in this case, actually this is a commonly confused point. So by mixing, it means that it can contain character nodes as the children nodes. So by default, this is quite counterintuitive, but complex type can't contain character by default. Characters by default, but simple type can. Later we'll be looking at a category to clear this up. But yes, so by adding this attribute mixed equal to true, you are enabling the complex type to have characters as the children, so you can have some text. So this means that document 5 can be validated against schema 2, right? Because in this case, the only difference between document 2 and 5 is that document 5 has text in it. Okay. What about 3? 3 should be quite straightforward, right? Because it has this decimal and it's basically a single node document. So it would be, which one? Let me check. Yes, 3, you're right. And for document 4, so yeah, schema 5 is basically specifying that the health element has an attribute called value and a type of integer, and this is required. So obviously 5 validates document 4 because you can see it has the required attribute. Which ones else also validates document 4? 1 and 2. Yes. 1 and 2 also validated because the attribute is by default optional. So you can have extra attributes in your elements, but you can't have extra. You can have extra attributes, arbitrary attributes, but you can't have extra elements in your tree. And later we'll be looking at why that is. Okay. Well, actually, we'll now be looking at this. So XML schema is tested typically in very detailed manner. So this was this document. I summarized this myself from an official explanation, like from 2 decades ago or something. And this basically summarizes some tips I'd like to have for you, and some of the points that might appear in the exam. And you can access it via this link, so Kotlin/XML. So basically, there are a couple of things I'd like. So I will not read all the document through, but I will just highlight a few points that I'd like to draw attention to. For example, so the root of the type system in XML is so-called this, if you can see, this AnyType. Okay, it seems to be a very arbitrary name, but from AnyType there are 2 subtypes. Okay, we've seen the complexType, and you are also likely to see so-called the simpleType in the exam. And you can also specify and create your own types from by extending either the simpleType or complexType. Okay, and this is basically a categorization of this taxonomy of these types, and you can look at it later. But basically, I think, one thing I find this figure very interesting. So when you are trying to create your own type, first you need to decide whether you have, when you want to create a new type, whether you have elements or attributes, right, in your document tree. And if you have element content or attributes, then you need to go for so-called complex types. Otherwise, it's a simple type. Okay, and you can extend simple type later. We'll be looking at by adding so-called restriction. For example, you are restricting certain nodes to be string type or integer type or list or union. For complex type, you need to further look at whether you have allowed children elements, right? And if you are having children elements, then you should go for the so-called complex content. Okay. Otherwise, if you don't have any children elements, meaning that you only have, for example, attributes you want to add, then you will have so-called the simple content. Okay. So by giving an example, I have made up some examples from that official document. So for example, if you want to extend the simple type to user-defined simple type, what you can do is that, the PDF version doesn't have the syntax highlighting, but basically what you have would be, so for example, this simple type named myType, I'm restricting it to string type, and we have a value of Don Smith, and so you can extend this type by adding a restriction, meaning that okay, this element can only be string, and then you can use it. You can use it by specifying the type. DC basically is an arbitrary namespace that we've touched upon in the last session, and then you can specify the name of the element, and then you provide the string as this simple element, the content of this simple element. The same goes for complex type. Okay, so for complex type, there are 2 combinations. Basically, either you will have a complex type with simple content. Simple content would be only adding additional attributes to that content. So meaning that, for example, I have I have a type called my new name type, and then this type would have an attribute called position, and it's restricted to type string. And because I don't have anything else but attributes added here, so this basically is a simple content. Okay, and by creating this type, I can use this type below by specifying the type of my element being employee, and the type of my new being my new name type, and then you define the employee with the attribute position you added upon the primitive, the basic complex type. And same, you can do the similar things with complex content. But basically for complex content, what you would have additionally is the children elements. So in this case, you can have sequences. Like, for example, in this case, I want to have a name, location as the children element. And also you still can have attributes. But once you are having children elements, it's gonna be a complex content. And in this case, okay, I can still define an employee element with this type, but in this case, I can not only have the position as an attribute, but also I can define name and location, these two children elements. And yeah, one thing, this is the default setting. You can look at it in detail later, but here is what I mentioned. So both the simple type and the complex type plus simple content allow data and textual contents, meaning that you can have characters, elements in your document tree, but counterintuitively, for the complex type plus complex content, you need to have the mixed, if I can spell, mixed equal to true, this attribute set to enable characters as children elements. Okay. Here, for example. And there are also some nitty-gritty details I've listed when I was doing some exam questions. I found it's quite useful to have up your sleeve. For example, the min occurs and max occurs by default is 1. Okay. And you can have reference and type. You can look at it later, but optional and additional elements are not allowed because there is something called unique particle attribution rule. So this rule is defined in XML, meaning that you can always specify a very specific element in the document tree. So you can always uniquely identify any element in the document tree. Okay, but basically, this is a document I compiled for FYI, and just for some clarification from this document. But if you are interested, I highly recommend looking to this official document for detail. Any questions at this point? Yeah, question.
Means that when I'm defining a sequence and I want my document to be valid against that schema, it always has to include all the elements that are in the schema, right? So I cannot leave anything out.
Exactly, yeah.
Okay.
And always, in the exam, when you are given an a schema, look at the type of document is being specified. For example, in this case, it's complex type with sequences and its restrictions. Okay. Any questions? Right. Alrighty, so then we move on to some example problems. Yes, so for task 2.3, so this is the schema, and you might say, wow, that's pretty lengthy. And I'm afraid that you might also get even longer ones in the exam. So get yourself comfortable with the leveling. So I think you can just, when you get familiar with this kind of organization, you can level the document by looking at which level this attribute is at. And for example, the choices. One thing I'd like to highlight, so this is the schema that validates this document. one thing I'd like to highlight here is that in most cases, they will be defining, so in the solutions, they will be defining the attributes outside of the context if these attributes were to be repeatedly used in the document. Okay, so for example, so the choice type, it means that you can always, you can only have, you can have the minimum occurrence to be 1, and it's used here. In many cases, this kind of definition will be extracted out outside, and we can also define this a type individually, and this can also happen for JSON documents as well. Question?
So in the exam, is it possible that we get given like some horrible XML file, we have to derive like a schema for it?
No, so you don't need to manually write it. So typically you will be provided with 3, for example, documents with 3 schemas, and you need to do this matching as we did before.
Oh, okay.
Yeah, but what I like to highlight here is that you can have this kind of syntax defining a type outside of the main schema document, and reusing it within the document tree. This should be simple. Next, any questions at this point? No, okay. JSON schemas should be more straightforward. So there are 2 types. One is the standard JSON schema. Another is the JSON. The JSON is not as widely recognized as this JSON schema, but it's much more concise, as we will look at later. So in this case, we can have a document like this, and basically we are restricting, we are defining the document, each of the attributes in the document. And the reason being, we want to we want to know ahead of time before processing like millions of objects in our database, what kind of fields we will encounter, so that we can efficiently map to a table or other data structures, or serialize or deserialize, if you have heard about that. And keep in mind that fields are optional in JSON. So actually you can, you don't need to have these 2 to be validating this document, but it is recommended that you always have one definition for every single attribute. And if you want to enforce this presence of attributes, you need to have so-called required field, which is which we'll look at later. So by default, it's optional, and you need to specify the required field. Okay. Right. And this is the, so for task 3.3, what I like to highlight here is that, so you're still given a JSON schema, and you are supposed to provide an example document that it validates. Here, it has a syntax like this. I've been asked what this is. This is basically what I mentioned before for XML. You can define a field outside of the original schema, the normal schema. In this case, you are referring, so the hash is referring the in schema, so the in document, the in schema reference. So you are referencing the definition here, the Vigi definition, right? And in fact, this kind of external reference, this kind of reference can be also be external. I've created an example here for you, illustrating how you can do this across documents. So in this case, we are defining a document called schema2, and we have defined a document called schema1.json. If it's visible, yes. And then what you can do is that, let me highlight. So in this case, you have the definition. And in this definition field, what you have defined under the namespace NC an amount type, amount type, the currency code, these three attributes. And within the amount type, you can refer to the definition of amount by giving it a reference to here. Okay, this is one kind of reusing. And similarly, by the same token, you can reference the currency code by using this kind of syntax. And also, what you can do is that here, the dot is referring to the current directory. So meaning that I'm referring to the definition, or I'm referring the definition of amount to another document, which is under the same directory as schema 2 in the schema 1 document, and you can find the definition there. Okay, any questions? So yeah, just to keep in mind that you have this kind of options, and this is called the in-schema references and cross-schema references. Okay, other points I think is pretty straightforward in the notebook. And any questions at this point? Question?
The two schema files are in different directories. Can we reference it?
Yes, you can reference it by providing the path to that file. Yeah. All right. Let me just. Yeah. Other questions? No. Okay. I will also upload this document to the repository, and yeah, if you have any questions, just to have a look and hit me up. Okay. Next, we'll move on to Dremel. For Dremel, I think the most common questions I've got is why we're doing this bizarre stuff, right? Like, it's just so weird that we're transforming a kind of not making sense kind of format to another not making sense kind of format. That's why I think I'd like to give you a bit of context as to why we are doing this by giving two Fs. So one is the facts and one are the features. So actually, Dremel is one of the seminal papers in databases. The paper was very influential, and Dremel is basically the backend of Google BigQuery. So BigQuery is basically a web portal where you can import some your queries, and you can get and also upload your data. For example, the archive of GitHub code, and then you do some queries on it. But under the hood, it's really it's Dremel that's doing the heavy lifting. And it is a petabyte scale NoSQL search engine. So it's operating on petabyte scale. And it's always, and one key feature is that it has constant execution time. Of course, you have the parentheses, but it's basically guaranteeing you that regardless of your data size, it's always giving you back the results of your query in relative constant time. And it's faster than MapReduce. So prior benchmark has shown dramatic improvement over the baseline of MapReduce execution. And you have, and this is being powered by other Google services like Analytics and AdSense. And the two features I like to highlight here is the data model that we will be looking at, which is protocol buffers version 1 is being changed a lot. And if you use Golang, then this should be a common type. You're doing serialization and deserialization. This will be covered today. And another, I think, is even more fascinating is the query execution. You have the server tree and how the in-memory shuffling is done via this server tree execution plan. But we will not cover this in this course, and I would recommend looking at this course, SAMU, Advanced Database Systems. I think most of you have heard about it from Andy Pavlov, the lecture 19, and it has a very detailed introduction into how it works. Okay, and today we'll basically cover the data model part. Right? So first, protocol buffer. So why do we have this protobuf? So first thing I'd like to highlight here is that once you are operating on a petabyte scale, what you need to care about is that the data conversion has to be very careful, because you can't have like petabyte data after transformation. You have even larger amount of data, right? You can't handle. So you can only have more or less similarly equivalent amount of transformed data, or even smaller. That's better. And what we want to do is that we want to convert JSON-like data. So by JSON-like, I mean really messy data type, tables with nested and missing fields, and into a columnar representation. So who have heard about column stores? You guys should all have heard about column stores. We've covered the white column stores. But why do we want a column representation instead of just tables? But we want column representations. This is the same motivation as we had for the column store.
You want to store all the relevant data together?
Exactly, yes. So you want to store all the relevant data together. That's a very concise answer. So in other words, what we want to do is that, why we want to do this is that we want to do analytical queries, right? So in this, for example, a very common use case in a real world scenario is that we have a table like this, right? And a white column table, and we have thousands of columns of attributes. I don't know, for employee, you have salaries, you have performance of every year, so on and so forth, right? And this can have, I don't know, thousands of columns. And what you want to do, especially when you're doing, for example, Google Analytics, you would be looking at, well, what's the average salary, for example, for the whole employee? And what you are looking at is not the whole database, but certain columns, right? And if you were to store this like huge table record by record, and you want to do analytics on this table, what you need to do is to retrieve the whole table, right? That would be very inefficient because the table could be very wide and also potentially very long. What you want to do is that you only want to retrieve relevant data. So in this case, it's only the two columns, right? So if your table were to stored in a column format, then you can only retrieve the relevant information, the information relevant to your query, instead of bringing up the other chunks that you don't need. Okay, that's the the core motivation why we want the column stores in the first place. Okay, and the second point is that we also want to convert this back, because still sometimes we want to, for example, the user is requiring the original data and so on. So if there are missing values, we need to keep it. Either keep it as a null value or something else. But we need to do this so-called lossless conversions. Let me put it this way. Okay, we need to preserve those null values, even if they are of no use. And in this case, the kind of representation we want to create is that, okay, for doing efficient query, we want to convert them to the column store, but on the other hand, we will still want to, given those column tables, want to blow it up back to the original messy data type we originally have, okay? So then in this, in this case, we'll be looking at how we can do this conversion. And I will be given an example from the paper, and I will show how I do this conversion. It's not the way to do it. It's not the optimal way, but it's the way that I typically do it, and I will summarize it later, but I will demonstrate you how you can do this conversion myself. Any questions on the motivation part? Question?
How are these like columnars stored?
Right. So basically, there are like several types of storing format in databases. So the question is how are the column stores databases stored in the storage? So there are several types. Chief among them are columnar storage, row-oriented storage, basically the relational databases, the traditional ones, and the mixed type that we've seen. For example, we have a group, several columns into a so-called column family we've seen before. But basically, they are exactly the same how they're stored. So they are stored in serialized binary format, but the only thing different is that for column stores, we're storing this in this order. So you are basically scanning the disk in this direction. But for column stores, you are storing the columns together. So basically, you are storing one column and another column and another one. So when you are scanning the disk, spinning the disk head to a sector, then that sector would contain a whole column instead of a row. Yeah.
It's some cases where a column can't fit on a single machine, isn't it? Like with petabyte scale data.
Exactly, right. That's why, yeah, so the question is, what happens if a single column doesn't fit on a single machine? That's why we have HBase, where we have range partitions. And each range server, a region server would handle a range of rows of that column. Yeah. Question?
But then how does, like, say I have a query where I want to get multiple columns, like how does it optimize for that then? Because what I saw with the Dremel format was, like, you have a replication level, but would you still not have to iterate through the different entries to figure out which ones correspond to your rows?
Right. So if I understood correctly, the question is, so in Dremel we convert, the representation of the original schema to basically a value plus two magic numbers, and the question is, well, if we were to know like which level of the table we're querying, do we need to also be aware of like the levels and the nestedness of that field? Is that a question?
Yeah, like I'm just trying to see how you can correspond like two values on the same row.
Mm-hmm.
Like I'm just wondering how you can get them to match up because through those two values.
Right. So let me put it this way. So if you were to have like a JSON document and you have nested fields, and in this case, if you were to translate directly to a table, what you have is a table within a table. So it's a cell within a table. And when you write queries, you would specify, okay, I want this column and this field within this cell. Maybe will have a nested SQL query within that small table. What Dremel or BigQuery does is that it has a translation phase. So it doesn't have, you're right, it doesn't have a standard SQL language. It has it extends. So the language you use to query Dremel is an extended version of the original SQL language. So basically, it translates your query into the nestedness of your field you are querying, and it matches directly into the column store, which means that you already know like which level this field is in, and it would be very efficient to scan the whole column because it's a flat representation. But yeah, later we'll be looking at how we do this kind of conversion. Yeah. Thanks for the question. Right, so having the motivation out of the way, we can look at an example from the paper. I was thinking of conjuring up some contrived example as I had before, but I found this example is very good. So to illustrate how this is done, so I've changed one thing is that the document type I changed from R1 and R2 to D1 and D2 because I found R1 is quite confusing. We are also using R as the repetition level. So yeah, so basically we have two documents. One is D1 and one is D2. And we have different objects, so many objects within a document, right? We have an object here, object group here, object group here, and so on. Sorry, we have, yeah, different objects within the single document object. So this is the so-called schema of the Protobuf. So actually, this is quite a verbose one compared to the newer versions, but this is the original design, and we will see why we need this schema if it's visible. And one thing I'd like to highlight here is the different types of the fields. So first, you have message. So basically, you can ignore this. So this is always present in the. So this is the root. Okay, and then you have the so-called required field. Optional field. Group basically indicates an individual object. Repeated, and yeah, so basically you have three types. Required, optional, and repeated. And still counterintuitively, the most important ones are the optional and repeated. And the required field, mostly we're going to ignore it. Why? Because if it's required, then it's required. So it's a must. So you have to have this field. So you have to have the document ID present in every single object, in every single document of of your columns or of your table. Okay. So you can think of a document as a table. So first, I will first go through this document to see how we can convert URL, so this field, to a columnar representation, given that we have, say, two tables or two documents, okay? Typically, how I would approach it is that first I will, because in the exam you will have pen and paper, but you can't draw on the computer. So on the paper, I would first suggest writing down the full path, okay, to the field. So in this case, we have a path from document to name and all the way to URL. Okay, these is basically the path to that field. And what you do is that first you number. So first you cross out all the required elements. So all the elements that must exist in the document. What I mean by that, I mean document doesn't matter because it's always there. Okay, is name required? No, name is repeated. Repeated, is URL required? No, URL is optional. So optional and required, they are very important. And then what you do is that you number them. So first you number name, and then you number URL. Okay, that's the second step. And third step is that you mark. You mark the repeated field. What I mean by that is name repeated? yes, it's a repeated field, right? Then you draw a small indicator on top of it saying, okay, name is repeated. Is URL repeated? No, URL is an optional field. Okay. Question?
What's the difference between repeated and optional fields?
Right. So the question is what the difference between optional and repeated field. The quick answer is optional field is something that you can either have one or none. And repeated field is that you can either have one or many. But for optional field, you can only have either one of them or none of them. You can't have many of them. That's the only difference.
So can there be an option repeated one? Or did you say repeated is one or more?
Yeah.
Or is it zero?
Zero or more.
Zero or more.
Yeah, yeah. So yeah, repeated optional would be repeated. Yes. So there are 3 steps I've demonstrated. First, cross out those required field. Second, number those non-required field, index them. And third is to mark those required fields. Okay. And then we start from the first document and we look for the URL. So from the schema, we know that, okay, the URL is under name, and we look at the first object. Do we have name there? Yes, we have name and we have URL. So the value is what? The value is A, right? So this is it. So the repetition level is always 0 when you are first encountering this field, meaning that none of the fields have been repeated. So either you can write this just whenever you encounter the first field in the document, then the repetition level is always 0, marking the start of an element, an attribute. Sorry. Or you can just say, when I want to evaluate the repetition level, you just look at the marks. So I've marked in the path, name is the repeated field, and I check name. Is name repeated more than once? No, so it's 0. So that's 0. And then what's the definition level? So definition level, you need to check along the path. So is our URL defined? It is defined, right? So is name defined? It is defined. So as long as URL is defined, then you take the last defined value, which is URL, and note down its index. In this case, is 2. Okay. Another example for the second element, what you have is B, right? Here. And the repetition level is what? By looking at the path, there is only one field that is marked being repeated, and you check if name is repeated. Yes, name is being repeated. Then the repetition level is the index of name, 1. Okay, and what's the definition level in this case? Well, you need to check. So along this path, is URL defined or not? URL is defined. Then what's the index of URL? The index of URL is 2. Note down 2. Another example. So going to another object, under name, do we have URL? No, we don't have URL. Quickly after this example. So what do we have? We will have a null, because from the schema we would know that the URL, if it's present, it will be under name. If it's not, then it's a null. So what's the repetition level? The repetition level will be, we should check if name is repeated. Yes, name is repeated. Again, we note down its index. And then is URL defined? URL here is not defined. So, but is name defined? Yes, name is defined. What's the index of name? Is 1. Definition level is 1.
Is it
Question.
index as in like index and document name URL, or?
Right.
Index as in, yeah.
The index is here. It's my index.
Your index.
Yes.
Okay.
So it's the way I do this kind of question. So your first index, and technically I would also index this repeated field. So how many, for example, this is the first repeated field. If there were another repeated field, I would index this as 2, but since there is none, and also you have too many indices, I don't want to confuse you. So yeah, typically I will just number this as the index, and the index I'm noting down here is, yeah, it's basically what I've numbered here. Yeah, question?
My question is why we're not including, like, so, I have a couple of questions. So,
Yeah, sure.
What is the meaning behind message document? Like, is a message comparable to a struct in a programming language, or,
Yeah.
like, what's the semantics of that?
Right. So you're right. So typically, if you used Golang, have you used Go language? Go? Yes. So Go language is very similar to C language, and a message is basically, you can think of it as a TCP package. So what you do, what you will transfer, for example, you are communicating with a database, this is basically a record. They will be deserializing through the network, or serializing through the network. And on your side, you will provide this schema when you are deserializing the network package from your language, whatever language you would use. If you were to use C, then that would be a struct, yes.
So it's like a struct in motion.
Exactly, yeah.
Okay.
Yeah.
And I want to ask, going from the value A to B,
Yeah.
I would have thought there was a repetition of 2 because it's like r1.name.url and you repeat the r1.name, but you're saying you're only repeating the name.
Right. So what you are saying is that, if I understood correctly, this B, the repetition level should have been 2 because we are already repeating URL.
Oh wait, no, so, sorry. I see where I've gone wrong. It's r1.name1 versus r1.name2.
Exactly, yeah.
Okay, yeah.
Yeah. So the repetition you're looking at is always within this parent group. So if there were, for example, multiple languages repeating, then yeah, this language is repeated with respect to this language. And this name is repeated with respect to this name. And also, when you are checking a repetition, you also need to note it down if it's a repeated field. If it's repeated, then you should take it into account because I've numbered here, well, I marked here name as a repeated field. And when you are need to index them, yeah. Question, yeah.
Why is the repeated number of the null and 1 and not 2? Because we are in the third name element. So should we do 2 instead of 1? Like in the paper it says it's 1, 2, but like I was confused.
It would be r1.name3.
Oh.
So compared to r1.name2, it's only repeating the r1.
Do you mean this one, this field?
Yeah, exactly.
Yes. So the question is why this field, why this repetition level of null isn't 1? Sorry, isn't 2. Yes. So first, do you understand how like this number is derived from my method?
Okay, maybe not from your method. Or maybe not even from the paper.
Yes. So yeah, first, the way I am calculating this might be a bit different from the paper, but yes, the second point is why this isn't 2. So technically, the reason why it's not 2 is because the repeated level. So in this case, none of the field. So if you check the name group, the only field the only 2 fields are repeated. Are repeated fields. One is the name, and one is the language, right? And language here is not repeated. Neither is on the path. And it's only name has been repeated prior to encountering this null field. So along the path, there is only one field attribute that is repeated attribute, and only this attribute has been repeated along the way. And this is why we note down 1 here. If there were to, for example, another repeated field in between, and then this should have been 2. Question?
But in the paper, they define the repetition level as the common prefix between different values.
Right. I wouldn't look at the paper definition. It's very confusing, I have to say. Yeah, so yeah, I would recommend if you can understand this way of like calculating the field, then yeah, I would better adhere to like my way of doing.
Are they equivalent?
They are definitely equivalent. Yeah,
Okay.
I've checked, and also I've tried the same conversion from this document, blowing up back to the schema. It's the same. I haven't. I have to say the explanation from the paper. Well, particularly on the schema part was not terribly helpful. Yeah, that's why. Yeah. Question. Yeah.
Then why the repetition of A is 0? Because you still have name, right? So it should be 1.
Right. So you still have name, but name hasn't been repeated because it's the first object in the document and nothing has been repeated, so it's 0. So either you can remember it as this, or any field at the beginning of the document, his repetition level will be 0, demarcating the beginning of the field. And actually, this is also one of the motivations why we have 0 in the paper. So they are trying to distinguish between the English US and the English field. So they are trying to distinguish between these 2 fields by having a repetition level of 0. So you know where the document starts. Okay, thanks. Yeah.
Just to make sure that I understand correctly, so it will always be, the repetition level will always be the index of the last element in the path that is a repeated element, if this element has been repeated, has occurred before, right?
Exactly.
Otherwise,
Yeah.
okay.
Yeah, we will go through a couple of more, and hopefully by then it will be much clearer. Yeah, but yeah, it's hard to wrap your head around, so that's why I've allocated a few more examples for that. Yeah, thanks for the question. Let me finish up this example. So next we will be looking at another URL in another document. Okay, so what I've been looking at here, these are the fields from document 1. Right? So in this case, this would be a messy table, if you like, a messy table with repeated and missing fields. So not even adhering to the first normal form, right? Now we are looking at document 2, and document 2 has one URL, right? So under the first object name, then what do we have? We have /c. The repetition level is 0 because it's the first in the document. What would be the repetition level? The repetition level, what would be the definition level? Is 2, yes. So this is because we have URL defined, we have name defined, so we just note down the second index. Question?
So like the index for the repetition level and the index for the definition level, does it refer to the same index set, or does it only refer to like only repeated fields and only optional fields?
Right. So you're exactly right. So they are referring to different things. So when I'm saying the reason why I don't want to introduce another level of index is because there are already multiple indices. In this case, the repeated fields. The number of repeated fields is strictly smaller than or equal to the number of optional or repeated field. That's why you can reuse this index here whenever you are noting down the repeated field. But yeah, they are technically different.
So here, a repetition level of 2 wouldn't be possible because there's only one repeated.
That's exactly right. Yes. So there wouldn't be even possible to have r equals to 2. Yeah. Right. So moving on to the second one. So we have document, links, and forward. So basically we are going to focusing on the forward field, right? So the first step, again, crossing out document is often no use. It's required. It's always there. And then second step, numbering the link. Is link optional? Yes, links is optional. Is forward optional or repeated? Yes, forward and optional is repeated, is not required, so we index them, and then we check is the field links repeated? No. Is the links is the field attribute forward repeated? Yes, it's a repeated field. So you note down the repeated field here. And then we go into the document and to check the forward link. So in the document 1, the forward first value is, change the color. The first value is 20. The repetition value is what? Is 0 because it's the first in the document. The definition, what's the definition level of 20? Yes, it's 2. Typically, if it's not null, then it's typically the index of that field, because every field of this path has been defined. You have defined links, you have defined forward. Forward is 20. So in this case, the definition level is 2. Then we move on to the second one, which is 40. So the repetition level is what? So what we need to check is that, okay, is forward repeated? Yes, forward is repeated. So we count how many field has been repeated along the path. Only forward is repeated. So the repetition level is 1, and the definition level is still 2 because it's not a null value. The next value we're looking at is 60. Right? And the repetition value is what? Is 1, exactly. Because we have forward repeated, and I've marked a little r here, and we only have one field being repeated.
I would argue that in this case, then the common prefix isn't equivalent to this method then. Because if we were doing it by common prefix, we would have the way they show it in the paper, we'd have r1 dot links 1 dot forward 1, 2, and 3, and so they'd have a repetition of 2 based on common prefix.
I agree with that.
I see. Right.
No, so I agree with your methodology, because it's what they have in the, like that's the answer they have in the paper.
Yeah.
Their explanation very clearly wrong then.
Exactly. I totally agree. What I was doing is I'm trying to think of an explanation for the paper. Yes. So I think what they are trying to say is that you first need to match the common prefix, and then you count how many repeated field in that common prefix. So in this case, we have the common prefix would be links and forward, and document, and the repeated field is only forward, and there's only one attribute. You note it down 1. And I found it's a quite complicated way of thinking it. So I think, maybe this method could simplify it a bit. Yeah. But I totally agree with what you just said. Yeah.
But you produce like 2 different columnar like stores. Using the method in the paper and that method, like with different values for repetition level.
They should be the same. Yeah. Oh, my method, the documents produced by method should be the same as what they produce.
Okay, so
yeah.
they produce the same document.
Yeah. I think it's just a different way of putting it. Like my way is just a way of doing the exam questions, I think. Yeah. Yeah. Right. Let's continue. And the definition level is 2 because it's it's an existing field. Then so these are the fields for document 1. And then we move on to document 2. So for document 2, what do we have? For the forward link, we have 80, right? And because it's the first in the field, we have 0 being repetition level, and the definition level is 2 because everything is defined. Okay. All right. So hopefully in the following examples, you guys can take over. Then for the next one, we want to count the backward link. What do we do? First, we cross out the document. It's of no use. For the links, what do we do? And then we find the backward links, right? So the backward in the first document, we have nothing, right? So we will have, we'll have a null in the first document, and the repetition level is, is 0. And definition level? Yes, I should have marked this field first. So the links 1, 2, and backward are repeated. So the definition level is 1, yes. Because, why? Because backward is not defined. Which is defined is only the link, right? So the link is the first field at the level 1, we note down 1. So this is document 1. And then we move on to document 2. The first value is 10, repetition level 0, start of the document. And then the definition level is is 2, right? Because backward is defined. Whenever this field is non-empty, then we just take the latest value, its index, which is 2. And then we have another field being 30. In this case, here, the repetition level is exactly, yes. The repetition level is 1. I think you're referring to this index, but actually, I think I made a mistake by saying the indexing. By saying indexing, actually, you should count the number of field. So in this case, before we meet 30, we have encountered repeated field of backward, and backward is in the path, and it's a repeated field. So how many of them? We have 1 repeated field on the path. And the definition of was 2 because it's not null. And similarly, we have 80. The repetition level, 80 is 4. So yeah, that's the document 2. Yeah, I think you've got to practice a couple of documents to get yourself familiar with this methods. I'm not saying that this is the method you should do it, but I forgot to do this, and hopefully it can be helpful in terms of developing your own methods of doing this. Yeah, question. Yeah.
I was wondering, how should you approach problems like this? Like, should you just perform an algorithm on them? Because that's essentially what we're doing, for each of the paths. Or should you try to get the intuition around it? Because now we're just practicing an algorithm, and
right.
you only remember the steps you're gonna take. You don't know why they're all at least I don't know exactly why I'm doing them. So for the exam and stuff, is it enough to just perform an algorithm and then those problems will be solvable?
Yes, so the question is, should we remember, aim to remember those tricks of doing those questions, or remembering the general intuition and the design principles? So for the exams, yes, definitely remember the tricks. For what I wanted to say is that, so at least by this almost 2 decades of schooling, I've learned the difference between what is learning and what is education. So doing education is that you need to do something that you don't even want to do, but you've got to have it done. So that's what schooling is. But learning is different. Learning is that you need to learn the reasoning behind why we're doing all this rubbish. And that's why, so in the original exercise, we don't have like this kind of context. That's why I'm trying to provide why we are doing this kind of conversion, why we have different formats, and why this is beneficial. Typically, this algorithm, so what I'm doing here by hand, is written because it's very repetitive, right? So it's basically a computer algorithm that's doing by a program. But I think the most important thing in the long term is definitely the principle behind it, which is why we are having, as I said, this columnar representation, why we want to preserve null values, why we want to convert to these columns, and why these two magic numbers can help us keep the size of our document small. So after the conversion, for example, we have petabytes of these documents. After converting, we're still having a roughly petabytes, not more. And then by having these magic numbers, when we're converting them back, we can go from this to this still. So I think, yeah, the context is very important. Like for later research or like later artwork for designing. In the long run, but for the exams, you've got to remember the tricks. Well, at least that works for me. Sorry about that, but yeah, question.
I have a question about the null values. If we had like a third document that didn't have links, would that also create a null value for backward, or is it like any part of the prefix that is needed to create one, and then we would just have a definition level of 0 in that case, or how does that work?
Right. So the question is, if we were to have an empty document without the links attribute at all, do we need this null value field with the repetition level being 0? Yeah, the answer is yes, because we need to have this lossless conversion. So technically, no. For if you were to do a query on the document, you don't need that field to be analytically correct. But yeah, for backward conversion, you need that field. Yeah.
So any unique instance of a prefix that creates a null value.
Prefix. Yeah, by prefix you mean the path to that field.
Yeah.
Yeah.
Could be like documents, but I mean these paths could be as long as we want.
That's true.
So like any prefix to the path.
Exactly, and that might be inefficient, you might think, but like for I think the reason being is that for each field you only need to have maximum one null field to represent the whole group. For example, for link, you don't need to care about the repeated nested field within it by just having one null field to represent the whole thing, and the same goes for name. There could be multiple names missing, and one document could have millions of names, but for the document that doesn't have the name field, you can only using a null to represent the missing. Yeah, good question. Right, so quickly go through the rest of the examples. So for the rest of the example, I will just ignore document. So basically is the root message or the package or the name of the table, if you like, or the schema, the name of the schema of the table. And then what you do is that first you check name, is name required? No. So you index it as before. Language, is language repeated? No. Required? No. Is code repeated? Required here. Code is required, right? So what you do is that you cross it out. It doesn't matter because this field we're checking is required, so it's always there. And is name repeated? Yes, name is a repeated field. Is language repeated? language is repeated field, then we have done the marking of this path. Then looking into the document, what we have is that first we have the English US value as the code, right? And the repetition level is 0. Definition level is 2. Yes. And next we have in the, is that in? Yeah, in repetition level.
2.
Exactly. Repetition level is 2 because along the path, how many repeated field have been repeated? 1, 2. Okay, so there are 2 fields repeated, 2 repeated field that have been repeated. Okay, and the definition level is 2 as well. And next, we have a null because under this name we have no code field, right? The repetition level is 1, exactly, because if you're looking at, well, the null could have been here, right? So being this place, and we don't, do we have language, oops, do we have language repeated within this object? No. Do we have name repeated? Yes, we have name repeated before, so noting down 1, success, and the definition level?
1.
Exactly. Definition level is 1 because we don't have language defined. We only have name defined as the parent. So if you were to draw a tree, then only the name is defined along that path. So from name, language to code, only name is defined. Note down its index being 1. Question?
But for an, the language was repeated, but the name hasn't been repeated yet.
Right.
So why 2?
Right. That's a very good question. That's a very good question. So in this case, yeah, that's why I said counting. So yeah, my method is not perfect. So in this case, what you need to do is that, so language is repeated, right? So this is the latest repeated field. And then, yeah, so, yeah, so the latest repeated field, yeah, that's a good question. Then, yeah, in this case, yeah, you basically count all the way to the root. Yeah, but it works. It works. Yeah, but yeah, that's a really good point. I think I need to rephrase my methods, reinterpret my method again. So basically, so what he said is a really great point, is that in this case, language is repeated, name is not repeated. But I think here we can use the method previously mentioned, the common prefix. You have a common prefix, name and language, right? And within that, you have both fields being repeated field, and you count how many of them. And as you have marked 2 of them, so you say, well, language is repeated. How many of the repeated field on this path? Or 2 of them. But yeah, sorry, yeah. Thanks for pointing it out. Good point. Right, next one. So the code is English, Great Britain. So for English, Great Britain, the repetition level is what? So counting from here, is language repeated? No. Is name repeated? Yes. And counting backwards, this is the only one. Okay. So representation, repetition level 1. Definition level?
2.
Yes, 2. Because it's not null and language is defined, the index of language is 2. So, oops, it's 2. Then this is document 1. For document 2, what we have is that we have nothing, we have a null. Repetition level being 0. Definition level being exactly, because along the path, language is not defined, name is defined. The index, this is the first, name is at level 1, so node on 1. Trust me, this works. Next one. Okay, we are getting there. So we marked, so name is repeated field as before. Language is also, country is optional, not required. So, but it's not repeated. So we number them language level 2, country level 3. I can do better than that. Yes. And then, so the first value of country is US in document 1. And repetition level is 0, start of the document. Definition level is, yes, is 3. Next one, the country is missing here, right? So we have a null. Representation level is, sorry, repetition level. Repetition level is language repeated? Yes. How many of them along the path? 2. So it's 2. Yes, yes. Just to make sure. Definition level? 2 as well, right? Because country is not defined because it's null. Language is defined. What's the index of language is on the second level, right? And then we go to here. The country field is still missing, right? If we were to try to convert this back, we know that, okay, this field is missing. And what's the repetition level of this field?
1.
Yes, it's 1. And what's the definition level of this field? 1 is as well, because only name is defined. Here, we don't even have the language as we had for the previous null value, okay? And and then we have the country, Great Britain. The repetition level is, so here, yes, 1 because name is repeated. And what's the definition level? Definition level is 3 because country is defined here and the index of country is 1. Exactly. So I think you guys have got the gist of it. And then we have document 2. For document 2, the start of the is...
Question.
Yeah, sure.
Do you have to do some thinking about what the definition level is? Because as long as it is a value, it has to be the maximum definition level.
You don't need to think. That's the optimal level of doing these kind of questions. So in the exams, the questions were quite a lot. So I'm introducing this method is to let you not to think. That's the just to fill in the blanks if you are familiar with these methods. But to understand why they are what they are, and I would recommend even going a bit further, converting. So given those columns and converting it back to the original 2 documents, and you can do it. After that, you would understand why we need to do these 2 magic numbers to preserve those fields. Yeah.
But then you would need to create like a finite state automata, wouldn't you?
Oh, that's a deep question. Finite state automata, do you mean pattern matching?
No, given those documents, given those columns, how to create that document. Like it's a specific order how you should parse through the documents.
Right.
Because
So
there is a finite state automata in the paper which does that.
right. So is that doing parsing? I don't remember on top of my head.
So you begin in 1 column, and then based on repetition and definition levels, you switch states. So then you might go to another column.
Right.
And back.
Yeah, that could be. Yeah, that could be. Yeah. So I would. Yeah, I
Because
think.
then,
Yeah.
Then you can like return a document that is not complete. Like if you're only interested in some fields, you can just write a finite state automata that extracts like those fields from the columns.
That could be. Yes. I need to look into it further to responsibly answer that question. But yeah, that's an interesting point. Yeah, I will look into it further. But thanks a lot for bringing it up. Yeah. Yes, good point. The last value. Yeah, for the country. So for document 2, the country is missing. So we have a null value. Representation level is 0 because start of the document. Definition level is, what's the definition level of? Yes, because we only have name defined because the null value would have been here. Right. Yes, I think you guys don't have the move of doing the exercise here. So yeah, this is the solution. I copy paste from the paper, and so basically just to quickly summarize the methods. So for Protobuf, what we have introduced like converting from a messy document data, for example, JSON with missing values, to a columnar tables. Okay, and what we to columnar tables, what we do is that first we write down the full path to the field that we're considering. For example, dog field, field A, field B. Okay, then what we do is that we ignore the required field. Okay, because they are definitely there. We don't need to specify them in our columnar table to be able to convert them back to the original representation. And then we index the remaining fields, right? For example, we've got rid of dog, and then what we do is that we index these 2 fields, right? And we mark the repeated field, for example, field B is repeated. And then the repetition level is the index of the last duplicated repeated field. I was reluctant to say repeated field, but yeah, so the index, not the index, yeah. Yes, the index. So if we were to have 2 repeated fields, then this is the first, this is the second, and if this field is repeated, this would be the representation level. Repetition level. Okay, and for the definition level is the index of last defined non-required field, because we have crossed out all the fields non-required field required field already, so the index is already there. So we should have a bracket here. So this is the optional or the repeated field. Okay. Yeah. So, well, then we have the exercise. I wouldn't bore you with. So I would highly recommend trying it out with this method. Maybe give it a shot. It's not required to convert it back, but it really helps in terms of understanding. But yes, this is how I would do this kind of questions, and I would highly recommend practicing it with the exercise questions, and the answer is also provided in the notebook. Let me check. Yeah, that's it, guys. That's all I wanted to cover in this session. Any last minute questions? Nope. Alrighty, then I think we've got a couple of minutes back, and I will stick around for any potential questions from the exercises or the lectures, and thanks a lot. Yeah.